Hello. So in this video we're going to look at another application of the law of cosines. And this problem comes from the book Analytic Trigonometry with Applications, right? By Barnett, Ziegler, and Bylene, 11th edition. So look in their law of cosines chapter. All right. So I went ahead and labeled a few things. The distance TS right here is 1,034 miles. The angle of elevation above the horizon, so they tell you the horizon's here, it's a horizontal, and the angle of elevation here, from here to here, is 32.4 degrees. And then they want to know how high is the satellite above the Earth at the time of the sighting. And the radius is 3,964 miles, but that's, remember, the radius is in every direction, so both of these are 3,964. And what they're looking for is the height that the satellite is above the Earth. That means it comes here, which means you have that little piece here. You have every bit here. You have from here all the way to here they want. So how do we find that? All right. So pause the video, give it a shot, and then I'll go through it. Now I just want to kind of mention to you that anytime you come with a vertical and a horizontal, you have a right angle, right? So over here, what you have with this horizontal line and then the vertical line, you have a right angle. So together, both of these, and you can add both of these right here and get the total angle, because it's going to be 90 plus 32.4, okay? So let's go ahead and work with that. So what I have now is a triangle that looks something like this, right? Where this is 1,034. This angle is 90 plus 32.4, right? So 122.4 degrees. So this is 122.4 degrees. And then what we also know is that this here is a radius, so that's 3,964, right? 3,964 miles. All right, so let's just take a picture. 1,034, 3,964, and then the addition of 90 plus 32.4. Okay, so now what the basic strategy is at this point is to go ahead and get this side, right? So you have this angle forms the side opposite it, and you also have the length of both sides here for this angle. So basically you could say, if I call this whole thing big D for distance, I could say D squared, right, using the law of cosines, is equal to 1,034 squared plus 3,964 squared minus 2 times 1,034 times 3,964 times the cosine of that angle, 122.4 degrees. All right, so now to solve for D, I'm just going to take the square root of both sides, right? So I'm going to take the square root here, and when you do that, D is going to be 4,601.62 miles, right? But that's this whole thing. So now if you look back at the picture, you know that from here, the center of the Earth to right at the Earth is 3,964, and then we want everything above the Earth to S. So altogether, this whole thing is D. So if I take the entire length of D and subtract out the 3,964, that'll give me this height that they're looking for. All right. So all I have to do then is take D minus the radius, right? So 4601.62 minus 3964 will give me 637.6, which I'll just round to 638 miles. All right, so that's 638 miles. That's it. There's the problem. Thank you so much for listening.